Hi, so we're going to be learning about the standard that is written in blue up at the top of the video. And in this standard, you're going to have to learn how to identify the effect on the graph of replacing fx by fx plus k and kfx and fkx and fx plus k for specific values of k. You are going to be experimenting with cases and illustrating and exploring of the effects on the graph by using technology. I forgot to mention in the beginning of the video to take out your notes, your guided notes that go with this video, and get out a pencil or a writing utensil and a calculator to figure out your answers. Okay, so don't forget to be writing this down in your guided notes. And here are some vocab and equations. And the standard form is ax squared plus bx plus c. And the vertex form of a quadratic is a parentheses x minus h parentheses squared plus k. And the parent function of a quadratic is x squared. So we're going to be learning about the parent function, and x squared is the parenting function of the quadratic depending on whether the x squared is positive or negative, which is going to tell you in the function that you are given. If the function is negative, it's going to open down, and if it's positive, it will open up. Here are some examples, like the one on the left is positive since the graph is opening up, and the one on the right is negative since the graph is opening down. You can also see that the one that's negative, it has a negative sign in front of the equation, which is another way you can check if it's positive or negative. This is the function of the vertex form, and you can see that it is a parentheses x minus h parentheses squared plus k, where a is what affects the width of the function, and if a is between 0 or 1, it gets wider, and if a is greater than 1, it gets smaller. You also have to know that h affects the x value of the function, and it can shift your function to the left or right in any form. If h is positive, it will shift to the right, but if h is negative, it will shift to the left. But be aware, there is a trick. For instance, if you saw x plus 2, you might think that h is positive. But since the equation has a x minus h, you are trying to find h, which means you had to plug in the negative number into h in order to make it positive. For this unit, you will have to remember the integer rules, and you know that two negatives equal a positive. So you can see in this equation that you are given, you see that it has two negatives, therefore it turns into a positive. Where h was originally negative, therefore the function shifts to the right. Another example is if we had x minus 6, it is positive because with the equation x minus h, you would write it out as the equation that you were given, right there. So that's how you would write it. And h was originally positive, therefore the function shifts to the right. Here at the top, we can see the original function that we were given. And in the bottom left, we can see how the function shifted 2 units to the left and how the one on the bottom right has shifted 6 units to the right. Continuing with the vertex form, the k affects the y value of the function. If it is a positive, it's going to shift up, and if it is a negative, it will shift down. Unlike h, there is a positive in front of k, so you don't have to worry about any tricks. Here are two other examples. You can see that in the first function, you are going to have to shift 5 units down since there is a negative sign in front of the 5. And in the next equation, you are going to have to shift 5 units up since there is an addition sign in front of the 5, which also counts as a positive. So this is your second standard that you will have to know, and it's up there written in blue, and you are going to have to observe using graphs and tables that a quantity increasing exponentially eventually exceeds a quantity increasing linearly and quadratically as a polynomial function. So here are some vocab words that you might already know, so I'll just go over them again. A linear is an equation that makes a straight line when graphed, and it is often expressed as y equals mx plus b. And a quadratic is an equation of a parabola and has one variable squared, and it's often expressed as y equals mx squared plus bx plus c. An exponential is an equation that starts with a constant line and then it starts going up, and it is often expressed as e with a exponent on the top. Here you can see the 3 types of functions in this graph, and you can see that they share the same x values, but overall the exponential function exceeds both the linear and quadratic function at the end. Finally, this is the last standard you will have to know, and it's up there in blue. And you are going to have to know how to fit a function to the data, use functions fitted to the data to solve problems in the context of the data, and you're going to have to know how to use given functions or choose a function suggested by the context, and emphasize quadratic models. Okay, so when given a function like the one above, you would have to find the vertex, and to find the vertex, you are going to have to use the equation negative b divided by 2a, which will get you the value of x. So you do the math that is shown in the video right now, the last bulletin. Once you find that, then you plug it into your original equation into the table key in your calculator, and you should get these points that are shown in the video right now. And now you know that you have to start with 4 since 4 was your starting point. And then you start with 4 with negative 10 and then graph it since that was your vertex that you found. And here you just simply graph it with the points that you were given, and then you are done. This video might or might not help you for the milestone. So yeah. This video was made by Rebecca Westbrook and Leslie Gonzalez. Hope you enjoyed.